I'm going to be, this is pretty loud, going to be speaking a bit about our migration strategy out of a black hole and kind of the next generation of the stuff that we've been doing. So, is this shit working? No, apparently not. So let's look at Klarna in short. How many in here know what Klarna does? Okay, then on this it goes really, really fast. We're kind of independent. We don't want to build a payment solution on top of the normal credit cards. We aim to double each year. We have over 100 million euros in turnover after 6 years. We've always been profitable. We're 800. We're doubling each year. This is a bit of a pain. We got Sequoia Capital, DST, General Atlantic, and Sensrum joined now this spring with Atomico. And most importantly, we love functional programming. And engineering at Klarna, we're around 170 at the moment. That's 100 Erlang developers. We have about 20 Ruby guys, and the rest is operations and kind of overhead trash like myself and the rest of us trying to be adding it. The vision for Klarna is to create zero frictions on the consumer base, and this is really about us removing some of the key friction bases or pain points within finance. And if you look at the whole financial ecosystem, it's a lot about building around identification. And how many in here uses PayPal? All of you, good. Because the whole thing with PayPal is that they identify you by first getting your credit card and then verifying it by sending a 4-digit code to your credit card. And once that loop is done, you're free to go. Klarna has just said, no, that's too much pressure. If you go in real life and do shopping, you don't have to do that. You don't have to register. Because we kind of see registration as the root of all evil. So we try and create, this is in Swedish, but this is our latest shit. I'm in a store, I've got some pumps, I've got a karaoke machine, I'm good to go for a really nice evening. We ask for my email address. And then we do this. This is incremental identification, as we call it. We kind of look, what store is it, what are you buying? And then we gather enough data points that we feel is good enough for us to do a real-time credit assessment. So in this case, we just ask for my zip number, and I'm good to go. I click, I'm up in 3 clicks now. And you're actually done. This is in Swedish, I'm sorry for it, but you got a receipt. You can actually change the payment options. We like using invoice, so people actually don't have to prepay. But if you as a customer want to use one of the classic cards, this is the stuff that we've been working on this year. So this means that we take about 100% of the, instead of just being an invoice option, we take 100% of our customers' purchases. But this means that we really need to have a very, very high availability. And this is actually a real pain. Because I've been working my whole life within the finance industry, and as a bank, you normally have the weekends to do all the mucky shit that you didn't have time to do during the normal bank days. And we're a 24/7 shop, so we don't have that option. So that kind of, we had a completely different challenge that we wanted to solve than the ones that we were having. And most of all, I'm a very firm believer that the SLA, or your availability of your services, is going to be the only thing that really differentiates us, and it's going to be the game changer for the services. Regardless of how good the product is, your consumers are not going to be using it if it doesn't work. And this comes back to kind of user experience, kind of hipster stuff. To be honest, this is my view on it. I live in Sweden, and if you're in the north of Sweden and there's a power outage, you kind of lift up this phone and you feel, my God, this is, I'm not alone. It works, you have a tone. Everything else is dead, your cell is dead, you don't have any electricity, you don't have any heat, but the phone works. And this is kind of what Ericsson and the guys had to solve, and the military sector and the whole society said, guys, you're part of our infrastructure, society's infrastructure. And this is what I've had on web, but nobody has really put that demand on them. So we needed to just acknowledge that availability is not optional anymore. And given the fact that our system today, or was, we are doing it, is a big monolith, we needed to create a migration strategy out of the dark pit of hell, as we call it internally. And that is all the technical debt that comes with doubling a company each year and not being able to scale, really. So how did we do that? Or target 4 nines, utilizing a very lean, no master environment, both when it comes to individual machines, clusters, or sites. And given the fact of our business, or kind of the behavior of our business, this is a bit of a challenge. So kind of in short, how we wanted to build this is that, of course, this is not something unique. This is pretty standardized. 2 sites, 2 firewalls, load balancers, clusters of front-end machines taking the applications, spread on 2 locations. But most importantly here, we only have 1 backend here. We're not replicating the whole structure between all the nodes. Because in our world, being able to be up is really, in this part, is being able to accept these purchases. And this is, okay, if you take it on this is a routing point of view. If you look at how we have built one of these front-end machines, if you dissect that, we are strong believers of having side effect functions that if this would be a purchase, something comes into here, goes to identification, that was stuff that I showed before. Okay, giving these data points, they might go and gather some data on the net if they want to. They get a data set, they can't rely on any other services. They add data to that data set and just pass it on to the next level. And then the whole purchase goes through these different silos and then are either go, no go, and the customer has a payment option provided to them. We are using React here, but we wanted to create an abstraction layer between the database and the services running on top of it. That was pain. That is pain. I'm not sure if that was the right thing to do in the phase. Just listen to Garrett Smith's Drunken Stumble. And this was one of these theoretical stuff that we did. It's good that we've done it, but was it the fastest way to get going? I don't know. So we're using React. We have this service orchestration engine. We have an abstraction. We have an MQ broker that's separating the fronts. This is just one machine, and of course we have a minimum of 3 nodes in each cluster, and then we can add as many clusters on a site as we feel like it. Given the fact that I solve some due diligence stuff with Amazon, I can scale on the cloud. I cannot do that as a financial player today, but I'm hoping to do that in future. And then we have the backend, which is, I'm not going to talk that much about it. This is the monolith that as soon as we've moved everything into this one, we're doing this step by step. I'm just going to start chainsawing through that one. The stack is we're using Erlang OTP, React, and RabbitMQ is really what we're trying to be using. And if you look on it on an infrastructure point of view, we have the XML RPC, that's kind of old stuff. We have a REST resource engine. We have a soapbox. We use the mashup stuff. It can go to external services. It can go to these internal side effect-free services. And we have the whole abstraction layer. And once the purchase is done, it puts the message to the backend for processing in a queue. Because this hasn't a state. It doesn't want to have a state. We don't want to have the whole purpose of this being totally independent on the front and the back end. So that back end can be down and the front end can act on their own to as large degree as possible. And just to simulate a service like this, how many guys in here, PSI, DSS, anybody seen these kind of evilness? Good. This is how one service could look like. This is our payment gateway. We're in the payment industry. If you want to create a PSI DSS vault, it's pain. And I wouldn't recommend anybody to do it unless you really have a good business case. So this is one of these nodes, okay? It does all these shit. You have firewalls, you have routers, you have storage, you have EDSs, you have logs, and you have all the shit that comes with being compliant. And most of all, you can't access this information because you need specified machines to do this. It's a very segregated environment. But we've built this as well. We're doing it with Erlang. We're using React and we use Rabbit. So we're trying to use the same tech stack regardless of what we're doing. on the stuff that we feel has any interaction with the user. This is so important. When the backend offline processing, we use whatever. Not that we're using PostgreSQL, we can use Java, we can use Ruby. Not that important. But when it comes to the transaction stuff, we want things that work. None of it's the bleeding edge. Sad to say, so I'm not the bleeding edge kind of guy. But it's not that old as well. But we're kind of not on the forefront. ZeroMQ, I was looking at it. It was a bit too bleeding, to be honest. So Rabbit was kind of the safe choice. So if you look on this one from kind of conceptual business point of view, we do not have a master. We do real-time credit scoring, and we do real-time credit card processing. And this concept doesn't really work well once you describe it to a risk department in the first pitch. That we're going to be spreading out the purchases, there's going to be shit happening in the back end, there's going to be shit happening in the in the front end, but we want to be able to do this because it creates a very high availability. And of course they're going to say it's not going to be synchronized. Yeah, because if a customer comes, of course we're going to use sticky sessions. We're not going to be stupid. So okay, we're going to try to use, so we have one cluster here. Of course the user is going to get directed to that cluster. But to be honest, if that cluster is gone, yes, he's going to get somewhere else. And if this whole site is gone, he's going to get routed somewhere else. And if you look on it, on any perspective, yes, we say that, okay, because it's in the behavior of the information. Because what we have, I come from the trading industry where you have machines, and if you look at risk is more in definition that what's the odds of you, what's the probability of you making a bad decision within a certain time frame due to missing data. That's kind of the risk when you're doing order validation, trading power calculations, and these kind of things. The same when you do credit scoring. And if you have machines that do multiple thousands transactions a second, you need a certain kind of technology to solve that. But if you don't and have human beings on the other hand, they click. And as soon as somebody starts clicking on things, they may be very fast, but they're not sub-second. They can be, but it's, you have to be using stuff like seconds instead of micro milliseconds. When you have that, you have a totally different problem to solve, because then you can have these multiple sites using actually the good parts of eventual consistency, because then you could have say that we put up a data center in Brazil, we have 400 milliseconds round trip Sweden to Brazil. It doesn't really matter. Say that it takes 3 seconds, worst case. Of course, we think it's going to be sub-second, but say it takes 3 seconds due to some whatever congestion in the system. It doesn't really matter. Because the human behavior is that if I'm shopping, I click, oh shit, I forgot something. I need to go and fetch it. I'll go into, I want to add this one, or I want to change. I bought 1 pair of socks, I want to buy 2. Whatever you're doing, the interaction with your computer or your mobile is on a second level. And this is kind of how we wanted to be utilizing this. Yes, we want to create the high availability and actually lowering the credit risk, because we're having human beings out there. So we don't have to be that fast. And this is very important when you're designing a system and looking what kind of toolbox you want to be using, is that what is the problem that you need to solve? It's so easy saying that everything needs to be so bloody fast. It doesn't. It's like REAC. Why do we choose REAC? It's a very slow data storage. But it is master. It's master 3. It doesn't have a master. And this is the point with it. Because this is what I wanted to achieve. I didn't want to have the very, very fast stuff. I could have gone with Mongo then. But Mongo does have this old kind of, to be honest, 80s, 90s approach to master-slave. And I don't want to build a system like that. Because I want to build something that scales in a totally different manner. And what's the SPOF here? It's not very hard to realize, but what happens if the mother dies? Yeah, what does? Okay, what does the offline processing in the trading and financial industry? You have interest calculations, you have fees, you have certain post-transactions that you do on a night batch, or if you're more modern, you don't have a batch, you do it when you think that you can do it. And to be honest, if we're solving payments here. So if we're missing an interest of 1 crown or 2 crown, and there's somebody wants to buy something for either $1 or $300-400, is that missing part of the data, is that so very important? It is important, but it's not that important for us to be able to make a go, no-go decision. So, of course, okay, mommy can die. Of course, mommy cannot be dead forever. That would be a certain issue for us. But it can be done for a pretty long time for us to actually be accepting the purchases. And of course, the next thing, if you, oh, this doesn't work, is that, okay, what happens if the whole routing entry dies? Of course, then we have to route the traffic some other place. That's how we integrate it, pretty simple. And then the last case, okay, what if our primary site dies? We can continue with life, but of course, we need to get mommy up in some day. But, you know, we have days now. We don't have the normal operating stuff that we need to solve stuff very, very quickly. So it's just creating this resilience in the system. And this is where if this is on a kind of routing perspective, let's look on that on a service, more into the code-based kind of structure. And how many guys are familiar with credit card system, how they work on a national kind of, yeah. The resilience that, if you look at the credit card market or the card market, it's this global entity of entry points of data that needs to be synchronized, and they need to find their way home. And how did they actually make that happen? And it's fascinating. I built debit cards processing stuff back in 2000, and I was just fascinated by how easily they've solved this. Because as an issuing bank, you can actually go into one of these networks, this Europay or MasterCard, and say that, okay, for these card series, if it's below 1,000 euros, say yes to it. If you try and answer us, we're down, just say yes to it, because we want to keep the consumer happy. He's there shopping, he doesn't want to be neglected or get his card, his purchase rejected. So just keep them happy. And I wanted to create exactly the same kind of structure here, using graceful degradation of services, so that, okay, say that we have a purchase comes in, the whole ID service is down, God knows why, but it's not giving the rest of the guys a level of identification. Okay, well, fuck it. Then the risk bubble there goes and says, yeah, well, I don't know who this guy is, but I have a pretty good idea of what he's trying to buy, and I have a pretty good idea on if he has his history or is his first-time customers. Okay, I'll give you some data more, but then the next guy might be dead. And this might continue down, so when we come down to it, okay, say that all these services are dead. Then we just enter it, okay, it's a flip a coin decision. Go, no go. And then you can work with a totally different way of modeling your risk, because then it's all about visualization. This becomes a market risk. Okay, just as long as you're visualizing, worst case scenario, say that we say yes to all the purchases without doing any kind of assessment at all. Okay, worst case is that all these are default, we just lose all the money. Then it's okay, how much is it worth for the company to have the uptime? Then it's marketing money. Yeah, shit, if it's below 3 million crowns, go with it. Just give us a panic button so we can start saying no. And this is where I really, really, really love the way you can build. Given the stack that you have Erlang, you have these very good technologies when it comes to kind of scaling stuff, and you have these very good principles of creating side effects tree. And if you combine that with some just common sense, you have this ability to be creating really, really robust structures. And this is something that I think is, it will be a big game changer when you start doing it. And now this isn't a high performance, it's not a low latency, high frequency system, if you're that kind of, this is a human system. This is solving the interaction with having humans. When I did some other kind of issues in trading, I couldn't build a system like this. But I wanted to demonstrate this, just first of all sharing how we are looking upon it, and looking upon how we chose a tech stack with regards to what kind of problems you want to be solving. And this is how we're doing it, and we're shipping it. Half of it's live now, and we're just taking it gradually. We're a bit holed up before because of Christmas. This is our peak moment in life, But this is the kind of migration strategy that we've chosen that actually allows us to be scaling. Given it that we go 100% fully live with it, that's going to be this spring. Operational scaling, the operations when it comes to accepting purchases, and the ability to put up data centers wherever we want in the world, it's solved. And it wasn't that much job. It's a hard thing to achieve, migrating out of the hole you were in. But when it comes to an architectural point of view and just saying that this is what we should be creating, it was pretty easy as long as you start understanding the fundamentals of the problems you want to be solving. Cool, that was actually it for me. I'm pretty fast. Questions? Yes.
Just in this picture, what happens when you need to deploy a new version of the MQ broker? Because there's a lot of sensitive information that's actually in the keys at the moment, and it's very nice for the captain, but might it become really platform failure or something like that?
I think as long as you can have buffers, you can just, I'm kind of used to having these very small services that you can just pull the brake and just say, as long as you can put a buffer saying that, okay, don't put shit into the MQ broker for now. And then you can just let everything in the queue get processed, and then you interchange it. But to be honest, I've worked a lot with IBM's MQ series, and they're a bit heavyweight. But my God, I never really changed it. Because once these things are stable, they just work. And it's very, very seldom. But having the possibility to be yes, I can create a queue with just buffering the information here. I can, in the same direction here, I can just start buffering this part. So you have and this is what I think I like with queues. And I like the fact that nobody, the guy who puts in the message here has really no idea on who's going to pick it up. And it could be anybody. And that's kind of the idea behind it. Yes?
So it seems to me that Klarna sort of accepts technical realities and lets them sort of bubble up to the business level of things. And do you think that it is correct that your title is CTO? I mean, you seem to have a lot of impact on the actual business by making decisions on the technical side.
No, I think that I'm a good bridge between it, but since the reason I've been spending my whole life within the finance industry. I started as a web monkey back in '94, stumbled into online trading in '99. So I have a very good understanding about risk and order validation. I've spent most of my time doing the derivatives and these kind of things. So that, of course, helps me. But it's also about having the engineering business sitting by each other, having the risk guys and stuff. Eventually, of course, there is you have to be some pedagogics. You have to be good when you explain stuff like this, that this isn't a risk. But at the same time, we still have the founders of the company very active in it, and they understand these things totally. They don't understand the technical side. They're from they're sales guys, to be honest, but they want to understand the technical. And of course, they have a bit of frustration of how long this takes. Why does it have to be certain types of engineers that are working on this and certain aspects? But we have a very good co-op on it, and we sit side by side. And I think that's the most. And this isn't my work. This is actually the team's. And as you saw here, I put the tags of the guys. If you put it here, Can Primates, Uwe and Masmanet, those are the guys who have actually been doing it. They are who should get all the creds when it comes to, implementing this idea and setting it on a general structure, and they're kind of very, very good at that. Good, more questions? Yes?
So with the eventual consistency model that you've adopted, for example, using React, and you've obviously got, you aren't completely consistent across all your data centers, for example. Do you take some of the risk decisions in there as well? So do you have any idea of what's your exposure if you lose a data center? So how many transactions are not yet replicated across to another site? Do you track any of those sorts of numbers?
No, but given the fact that data centers normally have 5 nines on them in their uptime, it's one of these issues that let's solve it when it happens, to be honest. I just wanted to have, when we designed it, to have the possibility to lose a data center without standing there or having this massive, what do you call it, plug. Let's go into phase B or DEFCON 6, and we have this hot standby site, but we've never used it. So, and I just didn't want to have that one. But how we actually would handle a full failure of a site that also contains mother, I don't know. Be creative, to be honest. But the SLA on this setup is lower than most of the data centers that we have, that we're putting into. So it creates that they really fuck up if this, to be honest. So I don't have a good idea about it. I think it's about collecting, having good visualization of the flows. We're working shitloads of the metrics, collecting it, and we have it here, so to speak, and we have it everywhere. We're trying to collect a lot more metrics. And since we're using Erlang, and we have some very, very good Erlang, these guys are collecting all the Erlang stats that we're trying to utilize. So I didn't have a good answer for that one, sorry. Yes?
Yeah, me again. So in the previous talk, you had a point that things are basically up most of the time. So how often are you down? Can you say something about that?
Today we have actually we have a really shitty SLA, to be honest. We have I kind of measure it really strictly as well. But since our system is built like a monolith today, it's an in-memory application. It works to a certain degree very well, but once it starts not working that well, it has real issue. Then you have timeout issues. It's a bit of serialization and it's a bit of processing that creates that something that happens in the backend system is exposed to the purchase. So we're at, I would say, a pretty bad 99.7 normal financial SLA at the moment, which is crap, to be honest. And the whole reason why we chose this migration strategy out of it is once we have the front end and have the availability to the customers, we can just put a chainsaw and start chopping up the rest of it. So it's more a practical approach to it. Okay. So today we're just normal, just due to the simple fact that we were working so. Klarna has been growing so very, very rapidly, and we've never had a product. This is also the kind of uniqueness. We just sell invoicing to the company however they would like to have it. So when I arrived at Klarna, I was like, yeah, so how does the product look like? We don't have one. We have like 6,000 different ways of tailor-made solutions, so to speak, with zero documentation, which just adds flavor to your job, makes it fun. Yes?
So you said you use sticky sessions, is that right?
Yeah, the general idea is to reuse sticky sessions here. The load balancers, yes.
So would that mean that if you lost one data center, then the user would have to restart their transaction?
And it's not actually the user because you have a customer who goes to the merchant and merchant integration with these libraries that they load from us. They have a backup plan to go to this one. But the effectiveness of that one depends, of course, on a lot of the infrastructure at the merchant side, how well that is utilized. So it's, but the case scenario that we lose one data center totally, I think we're gonna lose some purchases on it. But on the same hand, it's human beings. They click, even if they get, oops, something went wrong, like your Gmail, if it uses contact with it, you kind of click it and then you just try to refresh it and again. So you have, depending on what the customer is doing. We're trying to make it as resilient as possible, but it's very hard to be that when you have these totally outage. Any more? Yes.
Are you using Rabbit as your queue to the backend, or are you using other places as
Not
well?
to the backend. So we're using Rabbit for the backend communication between the threads, the thread cluster, so to speak, and to the backend. That's Rabbit. We've been looking at having it between the database as well for certain aspects as an abstraction layer, but we don't know how well, if that's really efficient, but it's just one of these.
Okay, so for the services that
but
use discovery and direct LPC.
Yeah, but we haven't gone down that path yet. And we like it a lot. The product's good. And we kind of like the React stuff as well. It's been working out pretty well. It's not fast. You shouldn't be using it if you need something that's really fast. But it's, from my point of view, it's the only database. Postgres and React was the kind of the key value store, and you need some kind of SQL environment for the kind of reports and the business parts of it. And those were the only two I found that were pretty. That was actually before Oracle bought MySQL, but it was, since I was guessing it was going to go in that direction anyway. But I've been working with Oracle, MS SQL, Postgres, and most of them, and I like them. Good. Please ask questions, because I'm really here to just share on what we're doing. So, and I'm, for a banking part, I'm that exact opposite. I want to share all of it. And I also want to, this is something we're working on with the legal, I want to open source. This is canned primates, it's Jacob's work, with the whole mashup orchestra. Once that's, we've gone through some of the legal stuff, I want to be outsourcing all of it. So hopefully in the spring, in Q1, I'm going to see a lot more open source code coming from us guys. Yes?
I'm just curious, you said you had a bunch of Ruby guys. Where are you using Ruby?
I didn't actually bring that up, but we do have a GUI. And so I have an office in Tel Aviv who's they're using Ruby on the new merchant, because the merchants are primary customers, and they of course need back office tools to be looking at purchase, to be changing goods and all these kind of stuff, looking at the reports on how the revenue is going. And we're migrating out that one because we built those things in Erlang as well. And this was kind of we being a 100% Erlang shop, not really efficient. I kind of believe in using the right tool for the job, and that's what and I think Uri, the manager we got, he got to choose. My only restriction was that, okay, we have one script language. You either pick Python or Ruby or Perl or whatever you want to use, but we don't have two. And I'm trying to stick to that one, not to get too fragmented on it. And they chose Ruby, which is working really fine for them. I didn't actually bring it up because the GUI, when it comes to because the transaction engine is really where it's the heart of the business is, but yes. Nothing else? Good.
My thanks to David for walking through. Please feel free to catch up with David after the session.